For this lesson, we're going to be talking about motion. This is an introduction to our unit on, it's going to be, we're going to talk about today distance and displacement. And tomorrow and the next days we'll be talking about speed and velocity, eventually talking about acceleration and deceleration. And we'll be finishing up this unit talking about Newton's laws, his first, second, and third laws of motion. And so today we're going to focus on the difference between distance and displacement. Since this is a unit on motion, the first thing we're going to talk about is what is motion. And today, for the most part, we had some good discussions about what motion is. And we were talking about how it's moving, and we asked for some examples of that. And we talked about whether or not something was or was not moving. And some students were really insightful today, and we're thinking about at the atomic level, things that have any heat to them are wiggling. And so that was great to see that people were thinking about that. And then some students even went the other direction, started imagining really big things. And again, there was some great thought going on about what is motion when you're talking about something. If it's sitting on the desk, is it really motionless? And so we had to clarify what we meant by motion. And what we mean by motion is a change in position. And so we're correct to say that the wiggling of the atoms on there is motion. And we were also correct to say that from outer space, since the planet is spinning, things are in motion. And so what we realized when we're talking about motion is that we really need to describe a little better about what we are relating it to. When we talk about motion, we need to be specific about in relation to what is it moving. Are we talking about an atomic level? Is it moving? Are we talking, is it just compared to the desk? Is it moving? Or are we going to take a really big picture and we're going to go into space terms and looking at from space, is it moving? And so motion is determined by relatively where you're looking at it from. And we talked about examples of being in the car, how things looked in there, even though they are not moving. We also talked about how things might look on an airplane if they're not moving. Today we are trying to emphasize the difference between distance and displacement. And for distance, it's going to be the length traveled in a lot of the problems that we're looking at. And for today and the problems we were doing, it was found by adding the length between the points that we traveled. A lot of the problems that we are going to be doing with distance, someone's going to travel from point A to point B to point C to point D, and we are going to add those distances together to find the total distance or the length traveled for the problems. And so in the equations and in the problems that we've been looking at, we've been trying to add those distances together to figure out the total distance traveled in our problems. The new word that we added was the idea of displacement, because we needed to clarify if you made a trip and you went really far and you came all the way back home, how far have you actually traveled? And it was unclear whether or not you've traveled really far or you haven't traveled at all. And so we clarified that by adding a new word to our vocabulary of displacement. And so this means the distance from the beginning to the end of your trip in a straight line. And so if your trip began and ended at the same place, then your displacement in that case would be 0. And so to solve for the displacement in our questions, we're going to be drawing a line from our starting point to our ending point and then measuring that line, and that will be the displacement from the start to the end. We talked about this as often we're going to be in our questions using a ruler and measuring from the starting point to the end point. And so we imagined going on a hike, and if you're going on a hike through the woods, you might be going around trees and up and over hills and down gullies. And so your trip might take, let's say, I think we use the example of a 5-mile hike that you did. And so the distance that you traveled may have been 5 miles along this path. Now the question was, from the area where you parked to where you ended, was that actually 5 miles, And no, in this case, maybe it was significantly less. Maybe this was only 3 miles from where you parked to where you ended up. And so we use this to show the difference between distance, which is the length traveled, whereas displacement is the distance from the starting point to the ending point in a straight line. Another way that we tried to clarify the difference between distance and displacement is looking at it from a baseball field, and we imagined if I'm up here now, hey, if you hit a home run and you started running the bases, you could travel 90 feet to get to first base, another 90 feet to get to second base, another 90 feet to get to third base, and then another 90 feet to get home. And so the total distance traveled here would be 360 feet. Most of us felt pretty good about answering that. We had a lot of blanks today when we were talking about what would the displacement be. And so let's clarify. Now this person started at home base and they ended at home base. And so if we try to draw a line from the start to the end point, well, we really couldn't draw a line because they are the same point. And since they are starting and ending at the same point, our displacement in this case is 0. In our next video, we'll be continuing on with this. We'll talk about speed, average speed, and velocity. Thank you very much for watching. We'll see you next time.